Okay, so for this question, since pi over 12 is not on the unit circle, we have to use some trig identities. So what I'll do is I'll just kind of Google trig identities. I usually just Google and use the first image. Here. We'll have to use either the half angle or the sum difference identities. So what we want, right, is we want to find either two angles that add or subtract to be pi over 12, or an angle that if I can cut it in half, and then I could use the half angle identity to be pi over 12. It doesn't really matter. Usually the half angle is easiest. Since we are doing sine, I'll do the half angle for sine, which is this one. So in my little thing here, get my pen, we're going to do sine of theta over 2 is plus or minus square root 1 minus cosine, all divided by 2. Theta over 2 is equal to pi over 12 gives that the theta has to be pi over 6. We get that just by multiplying both sides by the 2. So we get theta must be pi over 6. Plugging that into the identity, we get the square root of 1 minus cosine pi over 6, all divided by 2. And at this point, you'd want to use a unit circle. I thought I had one in front of me, but I don't see it anywhere. I must have put it down. Oh, here we go. So at that point, unit circle. So on the unit circle, we are looking for pi over 6, and cosine of pi over 6 is root 3 over 2. And then you can just solve this however you want. I would probably multiply top and bottom by 2 inside the square root. That'll give me 2 minus root 3 all over 4. And then the last part is that this is what sine of pi over 12 is equal to. The question was asking us to find sine of pi over 12 squared, which we get just by removing the square root over here. So the identity gives us sine of pi over 12. Then we square, and it removes the square root. So just to plug it in to make sure we're right, it's a fraction. 2 minus the square root 3, all divided by 4. So let's see. In the practice test that I have up here, I don't know if it's Ami or Amy, but we want to see 18 and 19. Probably close to the bottom. Not that close. Oh, here we go. All right, so similar kinds of questions. So for this first one, sine squared theta is equal to 3/4. First thing that we want to do is we want to square root both sides. So the square root of sine is squared is just going to be sine. When you take the square root of the other side, you do need to worry about the plus and the minus. Then you're going to do the square root of the top and then the square root of the bottom separately. Make sure you take the plus and minus of other side, then square root the numerator and denominator. Finally, we just use the unit circle to figure out where sine is root 3/2. So sine is root 3/2 plus or minus root 3/2 at pi over 3. It's positive or negative root 3/2 at 2 pi over 3, at 4 pi over 3, and then finally at 5 pi over 3. Cool. Any questions? So for this one, number 19, sine of 11 pi over 12, the half angle formula would be difficult. So we will use the sum formula for sine. And I hope I still have the identities up. Let me see. Yes. So this one. Sine of two angles added together is sine A cosine B plus cosine A sine B. So what we need is that we will need two angles that add to be 11 pi over 12. And I know that can be kind of hard. If you really want to, you could split this into degrees and figure it out that way, or just kind of play around with it until you figure it out. But I'm pretty sure that two things that add up to be 11 pi over 12 is going to be, well, 5, well, I shouldn't have been so confident. Two things that add to be 11 pi over 12. 2 pi over 3, so that's 8 pi over 12. And then we need 3 pi over 12, which is pi over 4. Is pi over 4? Does that work? Maybe? So that's 8 pi over 12 and 3 pi over 12. Let me just double check. 2/3 plus 1/4. And we want to see if this is 11/12. Yes. So what we're going to do is we're going to use our formula over here. Sine of 11 pi over 12 is the same thing as sine of 2 pi over 3 plus pi over 4, which from the formula is sine of the first angle, so sine 2 pi over 3, cosine of the second angle, cosine pi over 4, plus cosine of the first angle, cosine 2 pi over 3, sine of the second angle, sine of pi over 4. All right, and then you just plug in the different values into this. So again, using the unit circle, sine 2 pi over 3 is root 3 over 2. Cosine pi over 4 is root 2 over 2. Plus cosine 2 pi over 3 is negative 1/2. Sine pi over 4 is root 2 over 2. So multiplying these together, root 3 times root 2 is root 6. In the denominator there, 2 times 2 is 4. Minus, this is going to be negative root 2, all divided by 2 times 2, 4. And then these have the same similar denominators, so we can just subtract the numerators all under the one denominator. Keep in mind that with multiple choice questions, you may still have the correct answer, but not in the right form. So if I look at the practice test, that's not the right practice test. Where is the practice test? There. But I think we're good, right? Root 6 minus root 2 over 4, it looks like B. You're welcome. That's what I'm here for. Do you have any other homework questions? I have the time if you want to look at them now. Otherwise, we can wait. I don't know what okay means. Does okay mean, yeah, let's do it now? Or does okay mean, yeah, let's wait? I'm going to put the ball in his or her court. See what he or she thinks we should do. Cool. On 2.4, that's a lot of questions. Okay, let's look at them. 2.4, starting at 7. I should be writing down which ones we've done so far. So we did 1.3, number something, the practice test. We did number 18 and 19. And now with 2.4, we're starting with number 7. Ah, yeah, okay. Yeah, so this one's kind of hard. So here we're looking at limits. So the limit, come on. Come on, pen. Come back to me. Just put a new battery in this pen. It better work. I forget it. My fancy pen died. Give me a sec. Ah, we're back. Okay, so the limit. As h goes to 0 from the right, that's what that little plus means. Square root h squared plus 10h minus, 19 minus square root 19 all divided by h. So whenever we have funny square roots, we could try multiplying by the conjugate. So you should remember conjugate stuff from complex number stuff. Conjugate stuff works for this as well. We're going to multiply the top and bottom here by that square root h squared plus 10h plus 19, and now it's going to be plus square root 19. And we're going to do that on top, and we're going to multiply that square root h squared plus 10h plus 19 plus square root 19 on the bottom. All right, so when we do that, let me just go ahead and make this a little bit bigger. Foiling the top together, we'll call it numerators to be fancy. So this is going to be that square root times the other square root, and whenever you multiply a square root by itself, it just cancels out and you get the argument of the square root. So h squared plus 10h plus 19. The outer and the inner end up canceling each other out. Well, cancel. And then we just have negative 19 and positive 19 square root, so that again will cancel to just be the negative 19. In the denominator, I'm going to leave that with the h and then the square root h squared plus 10h plus 19 plus square root 19. Don't multiply out the denominator because we want the h to cancel out. All right, so what's going to happen is that this positive 19 cancels out with that negative 19. And now it's still the limit. I should have written that earlier and I kind of forgot. So the limit as h goes to 0 from the right, we have h squared plus 10h in the numerator. And now h times this awful thing, square root h squared plus 10h plus 19 plus square root 19 in the denominator. The h cancels in the numerator and denominator. I don't know why math made it so hard to spell numerator and denominator as often as I have to write those words. So the limit, as h goes to 0 from the right, we're just going to have a single h. The h canceled out from this one, so now it's 10. This h is now canceled, so we have the square root h squared plus 10h plus 19, and then over here we still have the plus root 19. At any point if you can just plug in the number and get an answer, then do that. We no longer get a 0 in the denominator, so we can just plug in h to be equal to 0. That is going to give us 0 plus 10 in the numerator divided by the square root of 0 plus 0 plus 19 plus the square root of 19. That is just going to be 18 up top. Not 18, sorry, that's my bad handwriting. 10 up top, and then we have root 19 plus root 19, which is 2 root 19. Finally, the 10 over 2 cancels, and we end up with 5 over the square root of 19. And then just to look good, let's plug it in and make sure. What's really interesting about this, and something that was brought up in class today, in my seated class, was when we start off, right, we're starting off with 0 up top. Where's the start off point? 0 up top and 0 in the bottom. So this is really the limit as 0 goes to 0, or as 0 divided by 0. 0 divided by 0 for this example ends up being 5 over root 19. So weird things happen when we have zeros. Is this okay? Any questions about 7 here? Awesome. So then 8, I think, was the other one? Where did it go? 8. Cool. For 8, this is one of those questions where there isn't really a set way of doing it. Here is how I would think of it. So first thing they ask you to do is you find the limit as x goes to negative 4 from the right of x plus 9 times the absolute value x plus 4 over x plus 4. If you just try to substitute in negative 4, you're going to end up with a 0 divided by 0, which is again like a really bad thing. Since we are approaching negative 4 from the right, you can think of it like we are plugging in numbers very close to negative 4 that are slightly bigger than negative 4, such as negative 3.999. So what this means is that if I'm plugging in something very close to negative 4 from above, the absolute value is always going to be positive no matter what. But the denominator, if I'm plugging in negative 3.999, negative 3.999 plus 4 is a positive number. The absolute value will always be positive, but the x plus 4 is positive when we approach from the right and negative when we approach from the left. They have the same value, so that ratio is either going to be 1 or negative 1. So when I'm approaching from the right, like I am here, this value, wrong pen, this value is just a positive 1, which really means that this is the same thing as just the limit as x approaches negative 4 from the right of x plus 9. And now I can just plug in negative 4 and get negative 4 plus 9, which is positive 5. The second part of the question is, well, what happens if I approach from the left? When we approach from the left, that ratio is going to be negative because the denominator is negative. So now, when we do the limit of x plus 9, absolute value x plus 4 over x plus 4, this is going to be negative 1. So it's going to be the limit as x approaches negative 4 from the left of x plus 9 times negative 1. And if I plug negative 4 into this, I get 5 times the negative 1, so negative 5. After we simplify down the ratio, we can just plug the number negative 4 into x. It said ration. Ration. I meant to say ratio. That's a hard question. But does it make more sense? No? I'm assuming this person's going to say yes, so we're looking at 14. I don't know why students do that. You ask them if they're okay, and they just say yes even when they're not okay. It's all right to say no. I don't always explain things perfectly. All right, so this is number 14, another one that they asked. So use the relation, the limit of sine theta over theta equals 1 to determine the limit, and we're looking at this. The limit as theta goes to 0 of 1 minus cosine theta divided by sine of 8 theta. What we want to get here is we somehow want to get either sine theta over theta, or we want to get theta over sine theta if we can. So we can't just plug in theta equals to 0 because sine of 0 is 0, which puts a 0 in the denominator. You could use the calculator for help here. So let me see if I can pull up my calculator. So we also don't have a theta floating around to use the identity given. So because there's not a theta on top and bottom just by itself that we could use with this that they give us here, we're going to kind of have to just play around with it and see what we can do. Oh no, my trial's almost up. So as soon as this loads, I'm just going to plug in the graph that we have here. Oh geez, I'm in like all kinds of weird things. So let me go back to function notation. Okay, and then we're just going to graph. So graphing this, the 1 minus cosine theta, that divided by sine of 8 theta. Graph. we are looking for what happens when theta is close to 0. From the graph, it looks like the limit should be 0. And let's just try it. Neat. He asked for some other ones. 16, 18, and 19. So same thing here. We have sine theta over sine of 9 theta, and we want to know what happens as my theta gets close to 0. I would just do the same trick. There are ways of figuring out what this is going to be by hand. And by all means, like, do it that way if you really want to. But I would probably just do this. I will say that this is probably going to either be 1 or 0 as well. If I had to guess, it would be 0. Yeah. Again, just graphing this one. It looks like the limit is approaching a y value of 0. Now, just because the graph looks like it's approaching 0 does not necessarily mean it's going to be approaching 0. So this shows that just because the graph looks one way does not necessarily mean it will go that way. So this one we're going to have to do by hand. So we're going to do the limit as theta goes to 0 of sine theta over sine of 9 theta. So if we want to use that identity that they give us there, the theta over, the sine theta over 1, sine theta over theta, and this is also the other way around. You could do theta over sine theta. I'm going to multiply top and bottom by theta, right? Because we're really just multiplying by 1. It's not a big deal. But when I do it this way, you'll see what happens. So I can write it as the limit as theta goes to 0. So what I'm going to do is I'm going to put the sine theta over theta, and then the other theta I'm going to put over the other sine, like this. Rearranging the fractions, we get this. These now somewhat match the relation given in the homework. The only issue is we should have a 9 times theta in the second fraction. And we can put a 9 up top here if I just multiply and divide by 9. So here we're going to multiply top and bottom by 9. So then I'm going to get the limit as theta goes to 0. We still have sine theta over theta. That we're just going to leave alone. But this one I'm going to write as 9 theta over sine of 9 theta. And I'm going to have an extra 1/9 floating around. Now, this is just going to go to 1 from the identity or the relation over here. This is going to go to 1. But then I have this extra 1/9 floating around. So all in all, that means that this goes to 1/9. The trick with these is to rearrange the fractions until you either have sine theta over theta or theta over sine theta. And the relation says these go to 1. You're welcome. I have to get ready for my 6 p.m. seated class. We can look at the others you asked next week if you still need help with those. I recorded this and talked through it. I'll upload this video to Moodle if you want to refer back. Have a good week.